Good afternoon, everyone. Welcome back to um, Algebra 2 with Pre-Calculus. I am Mr. Malcolm. I will be going through probability of multiple events today. We're going to be looking at different events and see how they relate to each other. And hopefully this will be informative for you. Please take the next 90 seconds to complete the Be Prepared section, which means that you need to place your math notebook, laptop, graphing calculator, and pencil on your desk. Update today's date, title, and make sure that you have an empty math page in your notebook because you will probably fill up a few today. Ensure that you're ready for your Zoom class meeting in a couple of minutes after this. All right, so be prepared. You can pause the video. And when you come back, we'll be ready to go. All right, see you in a few. All righty, so thank you for getting prepared. Today, our aim says, given a compound event, student will classify the events as independent or dependent. Student will be able to calculate the probability of multiple independent or dependent events occurring. So today's Think About It says, think about it. A probability experiment is designed such that you must flip a coin and roll a number cube. Giovanni says that the probability of flipping a coin and it landing on heads and then rolling a number cube and it landing on 3 is equal to 2/3 or 66.6 recurrent percent because 1/2 plus 1/6 equal 2/3 or 2/3. Do you agree or disagree with Giovanni's answer and reasoning? Explain and justify your answer. Okay, so right away we notice that we have 1/2. Where did they get this 1/2 from? From the coin. You have 1/2 possibility for it to be landing on heads. And then for the cube, we have 1/6 chance. Okay, since it's a 6-sided die, I imagine. Okay, now how would you go about solving the probability in a compound event? Would you add them or would you multiply them? Take a second, think about it. All right, if you guessed that you are to multiply them, then you would be correct. And not adding. If you recall, 2 days ago, I made that clear that you would multiply these in order to get the correct probability. So that would be numerator times numerator. 1 times 1 is 1. Denominator times denominator. So that's 2 times 6 is 12. So your answer should actually be 1/12. Now, why is it that it's not adding those two probabilities together and instead multiply? Well, let's take a look at what they end up having. Do you think that flipping a coin and rolling a cube and it landing on 3 would give you a very high probability, or do you expect it to be pretty low? Here, we see 66.6% chance. That's a very high probability. But in reality, does it really happen that often that you could get both of those happening at the same? Clearly not. That's not what's going to happen very often. As a matter of fact, you couldn't have a probability of 1/6 just for the chance of getting 3 and somehow magically make this 1/6 become even a higher probability when you have two things into account. So just from a clear logical standpoint, we couldn't have the probability becoming more, because as you add events, the probability ends up being less as you go on. Okay. Now, to explain and why or to justify this, you can do things like conduct your own experiment and see if this would be anywhere logical. Okay, but from the math would show us that the theoretical that we ought to multiply and not add. Okay, now I'll show you a diagram of how you could calculate the different outcomes. Now, to calculate the different outcomes, you would basically set up both of them. So for heads, you could have a heads with a 1, a heads with 2, heads with a 3, etc., etc. You could have for tails, you could have tails with a 1, a 2, a 3, 4, etc. When you do all of this, when you add up all of the different outcomes that you could get, you end up with 12 outcomes. Okay? That's much different from adding the probabilities. Okay? In this, they added the probabilities together. Now over here, one way that you can do it is by adding the outcomes or finding the sample space. Okay? And when you find the sample space, you'll see that it ends up being 12 different outcomes and not 2/3 would be 1/12. Okay, very similar to what I did up here. All right, so this is a different way to do the same problem. Either way, you should end up with the answer. But the thinking when you're doing these out is you have to take a step back and wonder, should the probability be more likely or should it be less likely? And that will lead you into the right path. All right. Thank you for stopping by today. Hopefully this was helpful and that you're able to finish the rest of the work for today with fairly ease. All right. Have a great day. And as always, continue to work hard. Bye-bye.